Hi, welcome to ASMTower software tutorial videos. Let's define the ladders. From the Geometry group, open the Ladder Geometry dialog box. We will define the climbing ladder followed by the feeding ladder. Each ladder consists of two parts. The first is the inclined part of the height of 0 to 45 meters, followed by the vertical part from the height of 45 meters to 55 meters. In the first row, we'll define the inclined part of the climbing ladder. There is no sort needed to the parts of the ladder. Set the bottom elevation equal to 0. Set the top elevation equal to 45 meters. Set the bottom radius equal to 2.94 meters. This is the direction of the x-axis in ASMTower. The azimuth measurement starts from the axis. The positive angle is clockwise. The azimuth angle is measured from the x-axis to an imaginary line connecting the center of the tower and the center of the ladder. Here it is equal to 135 degrees. Set the bottom azimuth equal to 135 degrees. Go back to the section at the bottom of the tower to review the radius and azimuth. The distance from the center of the tower to the center of the climbing ladder is 0.25. Set the top radius of 0.25 meters. The angle between the x-axis and the imaginary line from the center of the tower to the center of the ladder is 315 degrees clockwise. Set the top azimuth to minus 45 degrees, which also equals 315 degrees. Please pay attention. You can define the top azimuth equal to the bottom and equal to 135 degrees. But in this case, you should specify the upper radius by negative 0.25 meters instead of positive value. Using orientation, you can rotate the ladder around its center. In this case, the direction of the ladder is the same direction from the center of the tower to the center of the ladder. Therefore, set the orientation equal to the top azimuth and equal to minus 45 degrees. Set the clear width equal to 400 millimeters. Set the spacing of the ladder rungs or steps equal to 300 millimeters. Set the rail section angle 60 times 4. Set the rungs or step rod 20. But the list does not contain rod of this size, so it must be added first. Set Ka to 0 to allow ASMTower to automatically calculate it based on the ladder position. Click OK. Open the selected section dialog from the Geometry group. Copy any row and paste it to a new line. Leave the material unchanged. Modify section type to be solid round. Select the European standard. Modify the section name to be Rod 20 to be used as a rung or step in the ladder. Select this row. Copy it by clicking the keyboard Control button in addition to the C button. Select the first cell in a new row and paste it by clicking the keyboard Control button plus the V button. Modify the section name to be a Rod 10 to be used as a safety wire in the ladder. Click OK. Open Ladder Geometry dialog. Set rung section Rod 20. Set safety section Rod 10. Click OK. Click Update to refresh the graphics. The ladder appears in a 3D view. Rotate the view by clicking the plus Y button. To zoom in, rotate the mouse scroll forward. To define a ladder until the end of the tower, open Ladder Geometry. Copy the first row and paste it into the second row. Set the bottom elevation 45 meters. Set the top elevation 55 meters. Copy the top radius and top azimuth from the previous ladder part to the bottom of the current one. Set the top radius and azimuth to equal the values at the bottom of the current segment to make the current part vertically. Click OK. Click Update to refresh the graphics. The climbing ladder is now completed. Rotate the view by clicking the +Y button. To see the elevation view, click the Fit button. Click the XY button. Rotate the view by clicking the +Y button. To zoom out, rotate the mouse scroll backward. You may notice that the ladder is parallel to the main leg. After the elevation of the main leg bend, the ladder became vertical. To see the plan view, click the Fit button. Click the XZ button. To zoom in, rotate the mouse scroll forward. The ladder is located in the corner like a drawing. Let's define the feeder ladder. Open the ladder geometry from the geometry group. The feeding ladder is defined using 2 rows of the inclined part followed by the vertical part. Set the bottom elevation equal to 0. Set the top elevation equal to 45 meters. Return to the existing drawing tower. Set the bottom radius equal to 2.74 meters. The bottom azimuth should be 135 degrees like the climbing ladder. But we set the bottom azimuth equal to -45 to review its effect. Go to the section at the top. Set the top radius equal to 0.5 meters. Set the top azimuth equal to -45 degrees. Please pay attention. You can set the top azimuth equal to 135 degrees. But if you do, you should set the top radius equal to -0.5 meters instead of the positive value. Set the orientation equal to -45 degrees. Set the clear width equal to 460 millimeters. The distance between rungs or steps is equal to 1200 millimeters. Set the rail section equal to 12, where 12 is the number of the 60x4 angle in the profiles list. The rung section for the feeder ladder is a plate. We need to add its section to the profiles list. As you can see here, the rung is a plate. From the geometry group, open the Selected Section dialog box. Select the entire row and copy it by clicking the control with C. Select the first cell in the new row and paste by clicking the control with V. Modify the section type to be equal to the flat bar. Select the European standard. In the section name, select the plate 80x8. Click OK. Reopen the ladder geometry dialog box. In the rung section, select the plate 80x8. The ladder is not equipped with a safety wire or rail. Leave the safety section empty or equal to 0. Click OK. Click Update to refresh the graphic. Rotate the view by right-clicking and moving the mouse. You can notice that the feeding ladder is at a wrong position. It is far from the climbing ladder. Open Ladder Geometry. In the feed ladder, set the bottom azimuth equal to 135 degrees as the bottom azimuth of the climbing ladder. Click OK. Click Update to refresh the graphic. To zoom, rotate the mouse scroll. The ladders are now similar to the drawing of the existing tower. As you can see, the feeding ladder has rungs or steps with a profile of the plate. Rotate the view by clicking the +Y button. To zoom, rotate the mouse scroll. Move the view by left-clicking and moving the mouse. To zoom, rotate the mouse scroll. To see the elevation view, click the Fit button. Click the XY button. The two ladders are parallel to the tower main leg. Rotate the view by clicking the +Y button. The view is now perpendicular to the side of the ladder. Now we'll define the transmission line cluster. Back to the tower drawings. The tower is equipped with 18 feeders 7/8 of an inch arranged in 3 rows and 6 columns. The spacing between the centres of the rows is equal to 0.04 metres. The spacing between the centres of the columns is equal to 0.06 metres. These dimensions can be calculated using the specifications of the feeder clamps. To define, we need to add this feeder cluster to the database. On the top tab, select the database and click the Feeder Cluster button. Enter any name for the cluster. You should not use a name that already exists in the database. Select the feeder type within the cluster. Select 7/8 of an inch. The feeding cluster can be arranged in circular or rectangular cluster as in our case. Set the number of rows in the cluster to equal 3. Set the number of columns in the cluster to equal 6. Note that the row spacing is based on centre-to-centre measurements. Set the row spacing equal to 40 mm. Set the column spacing equal to 60 mm. Click the Add button. A message "Done successfully" means that the cluster has been added to the database. Click OK. Click Close. From the Appurtenance group, open the Transmission Line dialog box. The transmission line cluster consists of 2 parts. The first part is inclined and starts from 0 to 45 metres. The second part is vertical and starts from 45 metres to 53 metres. In the first row, we define the inclined part. Set the bottom elevation equal to 0. Set the top elevation equal to 45 metres. The bottom radius is the distance from the centre of the tower to the centre of cluster at the beginning of the cluster. It's equal to 2.64 metres. Set the bottom radius equal to 2.64 metres. The azimuth angle is measured from the x-axis to the imaginary line between the centre of the tower and the centre of the transmission line cluster. So in this case is equal to 135 degrees. The positive azimuth is for the angle clockwise. Set the bottom azimuth equal to 135 degrees. To get the top radius and azimuth, go back to the section at the top of the tower. The distance from the centre of the tower to the centre of the transmission line cluster is 0.55 metres. Set top radius to 0.55 metres. The angle between the x-axis and the line from the centre of the tower to the centre of cluster is equal to 315 degrees, measured clockwise. The angle value can be minus 45 degrees that is equal to 315 degrees. Both are the same. Attention please, you can set the top azimuth equal to 135 degrees like the bottom azimuth. But in this case, you should specify the upper radius by negative 0.55 meters instead of a positive value. Using orientation, you can rotate the cluster around its center. In our case, the cluster is oriented in the same direction as the ray from the tower center to the cluster center. Therefore, set the orientation equal to minus 45 degrees, similar to the top azimuth. In the cluster name, select the cluster name that we just defined for the 18 feeders. Set Ka to 0 to allow ASMTower to automatically calculate it based on the position of the feeder cluster. Click OK. Click Update to refresh the graphics. Move the view by left-clicking and moving the mouse. You can see from the 3D view that one ladder does not continue until the end of the tower. From the Geometry group, open the Ladder Geometry dialog box. Select the last row in which we defined the inclined part of the feeding ladder. Select a new row and paste the values. Modify the bottom elevation to equal 45 meters. Modify the top elevation to equal 55 meters. Set the bottom radius and azimuth equal to the upper radius and azimuth to make the ladder vertical. Click OK. Click Update to refresh the graphics. Now the feeding ladder reaches the end of the tower. To continue the transmission line to the end of the tower, open the Transmission Line dialog from the Appurtenance group. Select the first row and copy by clicking the keyboard control button with the C button. Select a new row and paste by clicking the keyboard control button with the V button. Modify bottom height to 45 meters. Set top elevation to equal 55 meters. Copy the bottom radius and bottom azimuth and paste to the top values because the current part is vertical. Click OK. Click Update to refresh the graphics. The feeding cluster is added until the end of the tower. To modify, open the Transmission Line dialog from Appurtenance group. Set the top elevation equal to 53 meters. Click OK. Click Update to refresh the graphics. To zoom, rotate the mouse scroll. Click Save. To see part of the structure rather than the entire structure, at the top tab, select Setting and click the Color button. Set the top drawn level equal to 6 meters. Click OK. Click Update to refresh the graphics. Only the first two panels are rendered in the 3D view. Rotate the view by right-clicking and moving the mouse. Rotate the scroll in the mouse to zoom. You see the climbing ladder using a safety wire, the feeding ladder and feeding cluster. It is great. To see the elevation view, click the Fit button. Click the XY button. To see the plan view, click the XZ button. The feeder cluster consists of 3 rows and 6 columns. Back to the drawing of the existing tower. Both feeding clusters are the same. There is nothing wrong. View the feeder properties used in the cluster. Select the database in the top tab, click the Feed Line button. Open the Custom group. Select 7/8 inch. It is a circular feeder with a diameter of 28 mm and a weight of 0.5 kg per metre. These are the characteristics of each feeder in the transmission line group. You can edit it or add a new feeder. Click Close. To see the characteristics of the feeder cluster, select the database in the top tab, click the Feeder Cluster button. Select the name of the cluster that we entered. You can see the type and number of rows and columns. Once this cluster is added to the database, you can use it in the current project or any future project without having to add it again. Click Close. To see the entire structure, select the setting from the top tab and click the Color button. Set the drawn level to a value greater than the height of the structure. To see the ladders at the end of the tapered part, click the Color button. Set the upper level equals 48 meters and the lower level equals 42 meters. Click OK. Click Update to refresh the graphics. To zoom out, rotate the mouse scroll. Rotate the view by right-clicking and moving the mouse. To zoom in, rotate the mouse scroll. Rotate the view by clicking the +Y button. You can see that the inclined part is perfectly connected to the vertical part of both the ladders and the transmission line cluster. To see the entire structure, select the setting from the top tab and click the Color button. Click Reset. Click OK. Click Update to refresh the graphics. To zoom out, rotate the mouse scroll. Rotate the view by right-clicking and moving the mouse. Move the view by left-clicking and moving the mouse. Rotate the view by right-clicking and moving the mouse. To zoom in, rotate the mouse scroll. Rotate the scroll in the opposite direction to zoom out. Also, you can use these buttons to do the same. Click the plus button to zoom in, minus button to zoom out. Click the Fit button to shrink the structure to fit the screen. To see the elevation view, click the XY button. Click the Y plus button to rotate the view around the Y-axis clockwise. Plus X to rotate around the X-axis clockwise. Plus Z to rotate around the Z-axis clockwise. Negative Z to rotate around the Z-axis anti-clockwise. Click the 3D button to reset the view rotation.